Hello, hi everyone. Welcome to the next video of this series. In this video, we are going to start with the organic chemistry, right? So the first important topic that we will discuss is hydrocarbons. So every chapter for organic chemistry, I have divided into basically 4 or 5 types, right? So in 4 or 5 types, first I'm going to discuss some questions which are related to basics. If I talk about the basics, it means I will incorporate those questions which are related to GOC, reaction mechanism and isomerism. Okay, then we have some questions related to preparation, then we have some question related to physical properties, then chemical properties. If you see the previous year questions and if you see the types of questions from the organic chemistry, so most of the questions they are from the chemical properties of every chapter, right? It means chemical properties with respect to alkanes, alkenes, alkynes, haloalkanes, haloarenes, alcohol, phenols, ethers, aldehydes, ketones, carboxylic acid, and amines, right? So these are the most important chapter of the organic chemistry, and these are only chapters in the organic chemistry. So what you need to do whenever you start solving question, first so you have to revise the GOC concepts, reaction mechanism concept, and isomerism concept, and then you can split the chapter into the topic wise, right? So this is my suggestion. If you do this thing, then you will get enough clarity about the concepts, right? Here I am going to write down the mechanism wherever it is possible. I'm going to tell you the most important reaction wherever it is possible, but by solving the questions. Because if I see one question, if I take one question of the hydrocarbons, so it may be related to aldehydes, ketones and carboxylic acid. Yeah, it may be related to alcohol, phenols and ethers. So the most important chapter of the organic chemistry is the hydrocarbons. If you do the hydrocarbons right in a very good way, and if you learn all the reactions, all the preparation reactions, then you can think like 60% of organic chemistry reaction you have completed, right? So this is the most important chapter out of all organic chemistry chapter. Okay, so let's start. So first let me tell you how to use this video. Obviously you have to revise short notes, but here how to revise short notes? First you have to revise the nomenclature part. Then you have to revise the GOC concepts, isomerism concepts, right? Isomerism concepts and reaction mechanism concepts. So these are the most important topics that you need to do. Okay. Then you have to write down the important information and the most common thing. It means you have to learn and write. Learn and write. If you know the reaction, just write it. Just write it. Okay. In order to retain all the chemical reactions, it is very important to write. You can write 2 or 3 times also, and then you can start doing the practice. And how to do practice? It means you have to solve questions. You have to solve questions. You can master organic chemistry by solving questions only. You can master organic chemistry by solving questions only. Understood? So you have to solve a lot of questions, right? Then first we are going to discuss the weightage, syllabus, mind maps, and then PYQs. So if we talk about the weightage, so if I specially if I want to find out ki how many questions are directly from the hydrocarbons, so we can say ki only one question at an average. But in organic chemistry, every chapter is interrelated with other chapters. So it means every chapter for organic chemistry is important, and the most common chapter is the hydrocarbons. Okay, I think I am clear on this. Next, let's discuss the mind map. So in the mind map, obviously, I am not going to write all the chemical reactions uh, which are in the hydrocarbons, yeah, which are in the alcohol, phenols, and ethers. So basically, in the mind maps, what you need to study, you have to study just hydrocarbon, right? It is divided into alkane, alkane, alkene, alkyne, alkyne, and aromatic hydrocarbons, right? Aromatic hydrocarbons. Now with respect to everything, yeah, with respect to every topic, what you need to study, you have to study these four things. First, preparation. Second, physical properties. Physical properties. Then you have to study chemical properties. Chemical properties. And last but not least, uses. And uses you have to study from NCERT. That's it. Okay, understood. Now I have divided the complete organic chemistry chapter, or this chapter of organic chemistry, into basics questions. Then we have the question on preparation. Then we have question on physical properties, and then we have question on chemical properties. Right. So basically, we have four types. So let's practice question. So in the first type, we are going to discuss some questions which are related to basics. Okay, I will let you know the basics, or I will let you know the topics when I discuss the question. Okay, let's do it. Let's discuss question number one. The compound which will have the lowest rate towards nucleophilic aromatic substitution on treatment with OH minus. So first of all, if you see all the options, so we have the aromatic ring, which is benzene, right? And we have substituents on this benzene ring. So nucleophilic substitution is difficult on benzene ring. On benzene ring. Why? Because in benzene ring we have high electron density. We have high electron density. And why do we have high electron density? Due to the presence of these double bonds. Right? Pi bonds can easily break, right? And it can form bond with the electrophile. So it has high electron density, or we can say it is going to be nucleophilic. It can act as a nucleophile. So why would nucleophile can attack on nucleophile? This is not a favorable situation, right? It's not a favorable situation. So what happens if we want nucleophilic attack on benzene ring, then what we need to do? We have to increase temperature, we have to increase pressure, or attach electron withdrawing group. And how to identify electron withdrawing group? Withdrawing groups, they are going to be X positive, or X double bond Y, or X triple bond Y, which can withdraw electron from the benzene ring. So electron withdrawing group withdraws electron from benzene ring and makes the ring electrophilic, due to which nucleophile can attack. Understood? Due to which nucleophile can attack. So these are the conditions. Okay. So see, if we see the option, so here we have one electron withdrawing group, NO2 is this, and double bond O and this. Now we can relate this with X double bond Y. So what happens? It can withdraw, suppose if this is the benzene ring part, right? So this bond electron comes over here, and electron of this bond shifts to Y. So it's an electron withdrawing group. So here we have one electron withdrawing group which shows minus M effect. Minus M effect means mesomeric effect. Mesomeric effect. Mesomeric effect. So first of all, we have different electronic effects. Now we can have minus M, we can have minus H, we can have minus I, we can have minus R. Right? So resonance in ring system is mesomeric. Resonance in ring is mesomeric. Okay. So all minus I effect, they are observed in case of electron withdrawing group, or in presence of electron withdrawing group. And if we have plus M, plus H, plus I, plus R, right? So all these effects, they are observed in presence of electron releasing group. So due to these effects, plus electronic effects, electron density on ring or electron density on carbon system increases. ठीक है? So here electron density on carbon system increases, while in the minus I effect, electron density on carbon system decreases. Now how to identify electron releasing group? Now they can have lone pair, they can have a negative charge, right? Lone pair, negative charge, or they can be less electronegative. Clear? Fine. Up now at ortho and para position, ortho and para, this is para position now, para with respect to this chlorine. So we have mesomeric effect. Here we have ortho and para position, 2 electron withdrawing group. So minus M, 2 minus M. Okay. Here we have ortho. So 1 electron releasing group. So minus M. Here we have NO2 group but at meta position. So mesomeric effect and resonance effect, it is only observed in case of ortho and para position, not on meta position. So here we have minus I. Why minus I? Because out of carbon and nitrogen, so nitrogen is more electron, or we can say more electronegative, right? So here carbon and nitrogen shared electrons, they are more closer to nitrogen, and we have the development of partial negative charge on nitrogen and partial positive charge on carbon. So the point is, the compound which will have the lowest rate towards nucleophilic aromatic substitution on treatment with OH minus, so that is going to be option number 4. Why option number 4? Because minus I effect is the partial polarization, or it cannot remove the electron from the benzene ring completely. It just electron, they are more closer to the nitrogen side, while in first, second and third we have electron withdrawing group where we can observe minus I effect. It means complete transfer of electron happens from benzene to nitrogen, or nitrogen, then we have nitrogen double bond na, then electron of this bond shifts to oxygen, right? Lowest rate is in option number 4 and highest rate is in option number 2. Why highest rate is in option number 2? Because we have 2 electron withdrawing group. So answer is going to be 4. Clear? Now let's do next question. Find out the major product for the following reaction. See, वैसे तो this is the part of alcohols. You can consider this is the part of alcohol, but we can simply apply the concept of reaction mechanism over here. How? See, we have this CH3 and here we write OH. ठीक है? Now we have H3O positive. H3O positive we can write as H2O in the presence of H plus, right? So we can write H3O positive. Now what happened in the presence of H plus? So see, oxygen has lone pair. So it is nucleophilic, or it is a nucleophile. H plus is going to be a electrophile. So what happened? Oxygen lone pair forms bond with the H plus, these lone pair, right? Due to which we have this situation. CH3 bete, then we write OH2 positive. Now oxygen forms 3 bonds na, here oxygen forms 3 bonds. So that's why we have positive charge on oxygen. Positive charge on oxygen. Now what to do? OH2 positive is a good leaving group. It's a good leaving group. And why it is a good leaving group? Because it leaves as water molecule. Okay. So what happens after this step? OH2 leaves. OH2 leaves. Water leaves. So we have the carbocation formation on this carbon. Carbocation formation on this carbon. So what do we write next? We are going to write like this. Here we write CH3 and here we write positive. Right? Why positive? Because now here carbon forms only 3 bonds. One bond with this carbon, another bond with this carbon, and one bond with the hydrogen. ठीक है बेटे. अब now what happens? This is 2-degree carbocation. This is 2-degree carbocation. We have the 5-membered ring. So in that case, you have to check whether you can rearrange the carbocation. मतलब here in this situation, you have to check rearrangement case, ring expansion case, and ring contraction case. Ring contraction case. ठीक है. We can do the rearrangement, we can do the ring expansion and ring contraction. So ring expansion is favored by, because 5-membered ring, 5-membered ring, 5-membered ring is converted to 6-membered ring, right? So now what happens? This bond, it dissociates. Now this bond has 2 electrons. So if I say ki both the electrons are on this carbon, so this is negative charge. So now we have the generation of positive charge, new positive charge. So here on this carbon we get new positive charge, right? New positive charge. And we are going to combine these two carbon atoms. ठीक है? Which two? These two. ठीक है? Now let me number this. So we have 1 number, 2 number, 3 number, 4 number, 5 number, and 6 number. Now I am going to form 6-membered ring. Okay. So let me form 6-membered ring like this. Okay. So this is 1 number, this is 2 number, this is 3 number, this is 4 number, this is 5 number, this is 6 number. Now if you see this, 1 number is bonded to methyl group. So I am going to write methyl group over here. 6 number is also bonded to methyl group. So I am going to form 6 number. मतलब 6 number is bonded to methyl group. And we have the new positive charge generation on 6 number carbon. ठीक है? Now if you see, this is cyclohexane type. No? This is cyclohexane. So here we have 1 hydrogen. Now what happens? Next part is the elimination. Next part is the elimination wala part. Okay. So what happened? The bond, this bond electron comes over here. ठीक है? So we get this alkene, right? We get this alkene. Clear or not? So this is the part of alcohol. So alcohol H2OH plus, we get alkene part, right? And which alkene? We are going to get this ZF alkene. ZF alkene as the major product. ठीक है? ZF alkene as the major product. And what is ZF alkene? What's it? ZF alkene? More alkylated alkene. More alkylated alkene. See, we have this situation. And we have positive charge over here. So beta elimination is going to happen. What beta elimination is going to happen? So carbon on which positive charge is present, that is alpha carbon. Alpha carbon, what is alpha carbon? Which is bonded to functional group, right? Or where intermediate is present, right? Intermediate is present. Okay, bete. So that is the alpha carbon. Now we have to look for beta carbon. So this is beta carbon. This is beta carbon. And we have this is beta carbon. So we have 3 beta. Okay. So if I remove, suppose this is beta 1, this is beta 2, and this is beta 3. So if I remove beta 1 hydrogen, then we get this alkene. Okay. This alkene. If I remove beta 2 hydrogen, then I get this alkene. Okay. And if I remove beta 3 hydrogen, so then I get this alkene. Now we have to look for which one is more alkylated. So see here, this is carbon, this is carbon, this is carbon, this is carbon. So we can say 4 alkyl. part. Okay, here we have only two alkyl part because two they are hydrogen. So we have two alkyl part, bete. Okay. Now let's check for the third one. We have one carbon, one carbon, one carbon, and that is hydrogen. So we have three alkyl part. So which one is going to be the more stable one? Which one is? Obviously, this is the more stable, na? More stable or major. Why this is more stable? Due to more alpha hydrogen. More alpha hydrogen means more hyperconjugated structures. Hyperconjugated structures. ठीक है? So it means hyperconjugation. If I want to find hyperconjugation, तो see ना, alpha hydrogen. This is alpha carbon. This is alpha carbon. This is alpha carbon. Alpha carbon. Carbon bonded to functional group. So here alkene is the functional group, right? So we have so many alpha hydrogens. So hyperconjugation, more hyperconjugated structure, it means more stability. Okay. So this is our answer. Now let's check for the options. So we get option number 2 as the correct answer. Clear? Simple reaction mechanism concept. If you don't know the reaction, then also you can do this reaction, this question. Okay. Now let's do next question. We have this completely based on reaction mechanism concept. So we have this situation. We have benzene ring and we have this part. Here we have alkene. Up now we have HF. Point is that, see, it can act as a nucleophile. Even this double bond can act as a nucleophile. If this benzene ring is going to act as a nucleophile, then the aromaticity is lost, right? So what happens? What happens here? This bond electron goes to H plus to form new bond and F minus removes, right? So we have this situation. So here carbocation is formed on this carbon, and here we have hydrogen, right? Because here we get 3-degree carbocation, na? So that's why carbocation is formed on this carbon, not on this carbon. Carbocation is not formed on this carbon, because if it is formed on this carbon, that is going to be 1-degree carbocation, which is less stable. Understood or not? So we have this situation. Now next part. We have benzene ring and we have this one, positive charge over here. Now what happens? This bond, now we do not have any situation, right? And this is intermediate, and intermediates are always reactive. So this bond electron comes to form bond with this carbon. Now what happened? One of the carbon, it forms bond with the carbocation, right? Carbocation. And on another carbon, we have the generation of positive charge. Positive charge. Now what happens? Now what happens? Here we have hydrogen. So F minus is going to act as base. Act as base. It will not act as nucleophile. Why? Because aromaticity is the major factor which stabilizes the molecule. So in order to maintain the aromaticity, it takes this hydrogen, right? And electron of this bond shifts over here. So we have the situation like this. ठीक है बेटे? Okay, clear. We have the situation like this. Now we have to look for the options and let's see which option is correct. So option number 1 is going to be the answer. Okay. Now let's do next question. Arrange the following compounds in increasing order of rate of aromatic electrophilic substitution. Electrophilic substitution, EAS. So for EAS, ring should be more nucleophilic, right? And that happens in the presence of electron releasing group. It means we have to look for electron releasing group, right? We have to look for electron releasing group. Okay, so how to see if you see this double bond, so this we can compare with the X double bond Y. So it is going to be the electron withdrawing group. Okay, bete, this is going to be the electron withdrawing group. Here we have OH. Now OH can give its electron to this benzene ring. So this is the electron releasing group. Right, bete? Here if you see, we have electron on this, which can increase the electron density on benzene ring. Even we have oxygen over here. It can give the electron to the benzene ring. So we can say, we can compare this with two electron releasing group. Here we have one electron releasing group. Right? What about this one? Here we do not have any resonance part. है ना? Here we do not have any resonance part. So here plus M we are not going to observe. So first of all, we have two electron releasing group in D. So answer is D. Then B, because one electron releasing group. Now out of A and C, here we have minus M effect. Right? Here we have minus I effect, minus M effect because it withdraws electron due to resonance. ठीक है? Due to resonance, but here it doesn't happen. So what happens? Now this carbon is bonded to more electronegative atom, so we can say here we can have little bit of minus I effect, because minus I effect, inductive effect operates at any position. Okay, so we can say D, B and A and C. So that is going to be the answer. Arrange the following compounds in increasing order of rate of aromatic substitution. So increasing, it means first you have to write where rate of electrophilic aromatic substitution is lowest. So the answer is going to be CABD. Understood? CABD is going to be answered. That's the increasing order. Clear? Easy question. Now, moving on to the next question. Which hydrogen in the compound E is easily replaceable during bromination reaction in presence of light? So basically, light, whenever you see light, you see UV light, or we can say extreme heat, or you see peroxide, it means you have to form free radical. You have to form free radical. So this is not the part of the reaction. You can easily understand by the stability of the intermediate. So free radical is formed. At the point is that where we can form free radicals. So we have CH3, CH2, CH and CH2. So this is alpha, this is beta, this is gamma, this is delta. So if I form free radical on alpha carbon, so that is going to be CH radical, and then double bond CH, CH2 and CH3. No free radical on double bond, not stable, not at all stable. Carbocation free radical carbon ion is not stable on double bond. Similarly, not on beta. No. If we see gamma, if I'm going to form free radical on gamma 1, so we get CH3, CH radical, then CH double bond CH2. So this is gamma 1. Up now this radical, free radical is resonance stabilized. This is resonance stabilized. Resonance stabilized. How? See, we have two electrons. So one electron moves over here. One electron moves over here and forms bond with this one. So we have resonating structure which looks like this: CH3, CH, then CH and then CH2 radical. So this is resonance stabilized, right? Or we can say this is allylic free radical. Why allylic? Free radical carbon on which free radical is present is bonded to sp2 hybrid carbon. So that is the allylic position, right? So that is going to be more stable. So it means which hydrogen in compound E is easily replaceable during bromination reaction presence of light? That is going to be the gamma 1. That is the allylic hydrogen. Okay, bete. That's it. Now moving on to the next question. The incorrect statement regarding ethine is the carbon-carbon bonds in ethynes is weaker than in ethene. So you have to find out the incorrect option. So ethine, we have triple bond, and ethene we have double bond. ठीक है? So you have to find out incorrect. The question says the carbon-carbon bonds in ethane is weaker. नहीं भाई, triple bond है. Triple bond is always stronger than double bond. Double bond. So we can say option A is incorrect. But let's look for another options. Both carbons are sp hybridized. बिल्कुल सही. Very true. True. Why it is true? Because here we have two sigma bonds now, one or two. So two sigma means sp, and here this is also sp. Okay. Next, the carbon-carbon bonds in ethine is shorter than in ethene. This is also true. Ethine shorter and stronger. Ethine is linear. True. sp hybridization. sp hybridization. It means linear geometry. So option A is going to be the correct answer. Now let's do the next question. Given below are two statements. Statement 1, SN2 reactions are stereospecific, indicating that they result in the formation of only one stereoisomer as the product. True. From SN2 reaction, you get racemic product. Not racemic, inverted product. You get inverted product. It means if the reactant has R configuration, then you get S configuration product. If reactant has S configuration, then you get R configuration as a product. So yes, it is stereospecific. This is true, bete. Next, SN1 reactions generally result in the formation of racemic mixture. Very true. If you have SN1 and you have the chiral center, then you get racemic product. You get racemic product. Racemic product means 50% S and 50% R. How to understand inverted in S? Suppose we have OH, we have CH3, this is CH2CH3, and this is we are going to write as H. Okay. So this is 2-degree alcohol. So 2-degree alcohol. So we can say SN2 can happen, even SN1 can happen in 2-degree. So what happens? Inverted product. See, OH is going to be the leaving group. If I'm going to react this with PCl5, so what happens? Inverted product Cl comes over here, H comes over here. Here OH leaving group is on right hand side. So Cl, which is a nucleophile, that is going to be on left hand side. CH3, and this is CH2CH3, and this is inverted product. Inverted product. ठीक है. And if I want to have, जैसे in PCl5 SN2 reaction happens. SN2 reaction is going to happen. But in case of retention product, so retention product is going to be like this. If OH is on right hand side, then the nucleophile is going to be on the right hand side. Understood? So that's the part of retention product. ठीक है? That's it. And now how to find out R and S? So you have to do the numbering on the basis of priority, and the priority you have to decide on the basis of atomic number. So oxygen atomic number is highest, so you have to give one number to this one. Okay. Then you have to give second number to CH2CH3, because carbon is bonded to carbon and 2 hydrogen. Here carbon is bonded to 3 hydrogen, so one carbon is extra over here in the second one, and carbon atomic number is more in comparison to hydrogen. So here you get 3 number and here you get 4 number. Now you have to move from 1 to 2. So when you move from 1 to 2, so this is the clockwise. This is clockwise, but lowest priority group, lowest priority group is on horizontal line, is on horizontal line. Let me rewrite this. It is clockwise. It is clockwise, but lowest priority group is on horizontal line. So this is S configuration. Okay, this is S configuration. So if you see this one, this is going to be R1. This is going to be the R1. See, just check. one number to this one, second number to this one, three number and four number, right? So 1 to 2 and 3. So this is anti-clockwise, but lowest priority group is on horizontal line. So you get R. Otherwise, if the lowest priority group is on vertical line, so clockwise R, anti-clockwise S. Okay? So this is R, and here retention product means here you are going to get S. So that's the part. SN1 reaction generally result in the formation of racemic mixture. Yes, if you have the chiral center. Chiral center should be present, right? So both statements 1 and true, we can say they are going to be true. Answer D is going to be the correct answer. Okay. Now let's do next question. In the given compound, the number of 2-degree carbon atom is a simple. Huh? It's just simple. What are 2-degree carbon? Carbon bonded to two carbons. That is 2-degree. If carbon is bonded to one carbon, then that is 1-degree. If carbon is bonded to 3 carbons, then 3-degree. And if carbon is bonded to 4 carbon, that is 4-degree. Right. So you have to find out 2-degree carbon. Na? So see CH3, CH3. Here H, CH, H, CH, CH3. And here we write CH3. So we have only one carbon which is bonded to 2 carbon. This carbon is 2-degree. है ना? This carbon is 2-degree. Now, this carbon is 1-degree because bonded to one carbon. This is 1-degree. This is 1-degree. This is 1-degree. ठीक है? And this carbon 3-degree. This carbon 3-degree because bonded to 3 carbon. So, number of 2-degree carbon atom is that is equal to 1. That is equal to 1. Okay. That's it. Now, we are moving to the questions which are based on the preparation of alkanes, alkenes, alkynes and aromatic hydrocarbons. So let's do it. Let's discuss question number 1. So what is question number 1? It says given below are two statements. Statement number 1, H2N double bond O. This is H2N, C double bond O, this double bond O and this. So if you see this group, right, this is amide, and if you see this functional group, this is ketone. Okay, under Clemmensen reduction. So what is Clemmensen reduction? What is the reagent in Clemmensen reduction? So we have ZnHg in presence of concentrated HCl. What is the use of this Clemmensen reduction, right? What is the use of this Clemmensen reduction? So it converts carbonyl, either aldehyde or ketone, RC double bond OH, or if we have ketone, so Clemmensen or Wolff-Kishner, right, gives alkane. So reduction means we can say addition of hydrogen. So what happens? Just removal of oxygen and put hydrogen over here, right? H and R. So we get alkane. So the point is that, so first statement says that under Clemmensen reduction it will give this. It will convert ketone to alkane, but ineffective with respect to amide. So under Clemmensen reduction from the first statement, from the first part, we should be getting this one. NH2, C double bond O, this, and here H, and here this. Understood or not? So we get this. Next statement, under Wolff-Kishner reduction, we get this one. So we have this Cl, double bond O, this one, right? ठीक है. Now it gives Wolff-Kishner is NH2 KOH in the presence of ethylene glycol, CH2S CH2OH. So what happens over here? So we get H and this. Clear? A point is this Cl, it is the base sensitive group. Base sensitive group means if we have Cl over here, so OH minus can attack over here and Cl can leave. Right. So here what do we get? In place of Cl, we are going to get OH, because here we have to do nucleophilic reaction, right? Nucleophilic substitution reaction. And what is in this statement? Ki we get Cl? So no. It means both statements are false. Both statement 1 and 2, they are false. So option number 2 is going to be the correct answer. Okay. Now let's do the next question, which is based on same type. So same type assertion says under Wolff-Kishner reduction, we get this. No, we get OH because that Cl is the base sensitive group. Base sensitive group. Okay. Now, Wolff-Kishner reduction is used to convert ketone to alkane. Yes, this is true. So, we can say assertion is false. Assertion is false, but reason is true. Okay, so option 2 is going to be the correct answer from here. Clear? Okay. Now we are moving to the next type of question, and in that we are going to discuss questions which are related to physical properties. And if I talk about the physical properties, so here we are going to deal with the boiling point, melting point generally, and one more, solubility in water. Okay, solubility in water. So what happens? Boiling point is directly proportional to molar mass. If molar mass is same, then you have to see the branching and all. So it is directly proportional to surface area. If more surface area in case of alkanes, then more van der Waals force of attraction. And if we have more van der Waals force of attraction, then more boiling point. Okay? And inversely proportional to branching. Okay, bete? Branching. Now, if we talk about the melting point, so again it is directly proportional to molar mass. Plus it is directly proportional to packing, packed structure or more symmetrical structure. And if we talk about more symmetrical structure, it means it is directly proportional to the branching. Now for solubility in water, they are generally insoluble because here we are talking about alkanes, alkenes and alkynes. Alkanes, alkenes and alkynes. So alkanes, alkanes and alkynes, they are insoluble in water. They are what? Insoluble in water. But if we talk about any other compound, then we have to check dipole moment. Dipole moment. We have to find dipole moment. If dipole moment is not equal to 0, then that substance can dissolve in water. Okay, understood. So let's do question on the same type. So question says the increasing order of the boiling point of the major product A, B and C of the following reactions. Now if you see the question, in this question we should know the reaction as well we should know the physical property. We should be having the idea of physical property. Okay. So first of all we have reaction with HBr. Okay. HBr and HBr. So what is the reaction with HBr in case of alkene? So देखो we have two. We have CH3, CH double bond CH2 suppose. And if I want to react this with HBr, if I say HBr dark, then what happens? We have to do Marconic of attack. And in the Marconic of attack, we have to form carbocation. And if carbocation is formed, then we can do rearrangement. Rearrangement like hydride shift, methyl shift, phenyl shift, or we can do either ring expansion or ring contraction. So this can also happen, right? So rearrangement. Now what happens? This double bond electron, it forms bond with this H plus and Br minus leaves. So CH3, CH and CH2. Now we have two things. If hydrogen is formed by this carbon, if hydrogen forms bond with this carbon, or we can say carbon number 1, 2, 3. If hydrogen number 1 forms bond, if carbon number 1 forms bond with the hydrogen, then we have the carbocation formation over here, right? Or we can say we can have this thing, CH2 positive. If hydrogen forms bond with the second number carbon, then carbocation is formed on the first number carbon. So here this is 2 degree carbocation and here it is 1 degree carbocation, because this carbocation is formed bond with 1 carbon, 1 degree. This carbocation forms bond with 2 carbon. So this is 2 degree carbocation. So obviously this is stable, more stable. So we get major product from here. So here we get now Br minus, right? Br minus can attack on this carbon. So we get CH3, CH, Br and here we write CH3. That is an HBr dark. But if we have this situation, HBr I can write light or peroxide. Then we have to do free radical mechanism, free radical. So here anti-Markovnikov happens. Anti-Markovnikov happens. So here what do we get? CH3CH2 CH2Br. That's Markovnikov, na? So as per Markovnikov, we get Br over here. So as per anti-Markovnikov, we get Br over here. Understood? That's it. On the basis of that, we are going to do the above question. So this is what C6H5C double bond O C double bond O C6H5. So this is peroxide linkage. So peroxide means we have to do anti-Markovnikov. If we have to do anti-Markovnikov, bachche, so it means A is going to be here. We are going to write Br, right? Then this H is going to be over here. Now HBr, we have to do Markovnikov because unsymmetrical alkene. So B is going to be here. We write Br, okay, and here we put H. Okay. Now third one C1. HBr, we have to do Markovnikov, but this is the symmetrical alkene. Symmetrical alkene. So symmetrical alkene, there is no need to do Markovnikov, anti-Markovnikov. So here we write Br over here or here, or we can also write Br over here, or like this. We can also write. A point is boiling point. We have to check the order of boiling point now. So boiling point is direct. If we see, let's see the number of carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1 bromine, matlab these are all isomers. So how to find out? In A, surface area is more. Surface area is more, or we can say less branching. So A boiling point is going to be more. Then we have C, and last we have B. Because in B may we have more branching, right? We have more branching. Clear? Understood? So answer is going to be option number 1, B, C, A. Okay. Now moving on to the next question. But2 is reacted separately with 1 mole of hydrogen as shown below. Okay. So again, reaction based question, but if you see the option, we have to understand the physical properties. So reaction plus physical property question. Okay, bete? So देखो how to find out. See, we have CH3C triple bond C and this is CH3, right? Okay, ठीक है. You have to add hydrogen. So first we have PDC and heat. So here from here you get A, and if you use Na in liquid NH3, so you get option number B. So hydrogen addition, it means hydrogenation reaction. So beta, this is called Lindlar's catalyst. So from Lindlar's catalyst, Lindlar's region, you get cis alkene. अब this thing you should know, याद होना चाहिए, right? Now for Na liquid NH3, so this is Birch reduction, and from the Birch reduction we get trans alkene. ठीक है बेटे, trans alkene. So if I form trans alkene, so we get C double bond C. If CH3 is over here, the opposite side CH3. Then hydrogen. If I want to form cis one, so C double bond C. CH3 same side, H and H. ठीक है. Ab now, in order to find out any property, what you need to check, you have to find out dipole moment first. Dipole moment, you have to find out. The first thing is to find out dipole moment. So see, this is sp2 carbon, this is sp3 carbon. Doubly bonded carbon is sp2. sp2 carbon is more electronegative, है ना? More electronegative. Yani we can say that electronegativity is directly proportional to percentage as character. Already discussed in chemical bonding, bete. So here dipole is towards this side, mu1, and mu2 is towards this side. कार्बन हाइड्रोजन बॉन्ड को वी कैन अज्यूम it's as non-polar type thing, right? So mu1 is over here and mu2 is in this direction. If you see, mu1 is equal to minus of mu2, due to which mu net is equal to mu1 plus mu2, which makes it equal to 0. Okay, now if you see over here, so mu1 here, mu2 here. ठीक है? So see, mu2 is going to be in this direction, mu1 is going to be in this direction, so mu net is going to be in this direction. Understood? Mu net is going to be in this direction. So here mu1 mu net is equal to under root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta, right? So in that way we can find out the dipole moment is not equal to 0. Okay bete, it means we have B, we have A. A is cis, this is trans. So here dipole moment is equal to 0, here dipole moment is not equal to 0. So question is A is more soluble than B. So cis dipole moment is not equal to 0. So yes, it is more soluble. So if it is more soluble, so this statement is true. ठीक है? Next. Boiling point and melting point of A are higher and lower than B respectively. It says boiling point of A are higher. Yes, A ka boiling point is more, boiling point more due to more dipole moment, right? But what about the boiling point and melting point of A are higher and lower than B? Up boiling point of A higher and true. What about of melting point? Melting point of A lower. Yes, melting point is lower. Why melting point is lower? Because see, in trans 1, two bulky groups are on different side. Bulky groups are on different side or opposite side, so less repulsion, or we can say more stability, so symmetry is more, so melting point of trans is more. Understood? But in case of C, cis, if you see cis, so two bulky groups, they are on same side. So symmetry is not there, repulsion is there, stability is less. So we can say melting point of A is going to be lower than in comparison to B. Okay? So it means this statement is also true. Boiling point of A higher and melting point A lower. Perfect. A is more polar than B because dipole moment of A is 0. No, dipole moment of A cannot be 0. Na? It is not equal to 0, dipole moment of A. A is more polar, so this is false. Br2 adds easily to B than A. No, this is also false. Why? See, when Br2 is added across double bond, right? So suppose this is H, we have H, or suppose H. Okay? Or we can say, let me form CH3 here, CH3 here, H here, H here. So when Br2 add now with A, so we have na bromonium ion formation. So this double bond forms bond with this one, right? Then either it can dissociate na, and we have lone pair, so we get over here lone pair, because if this carbon, if I say this carbon forms bond with this bromine, okay? So here we have the generation of carbocation na, and carbocation has empty orbital bete. So what happened? Bromine has lone pair na. Bromine has lone pair. So lone pair of bromine goes to the empty orbital of this. So we have the bromonium ion structure. So we have this kind of structure. C H Br positive, C Br CH3 H and H. So it happens in cis easily. This is called syn addition. So Br2 adds easily to B, then A. Okay? So it is false statement. Okay? That's it. So question says identify the incorrect statement. So what are the incorrect statements? C and D, they are going to be the incorrect statement. Okay? Now let's do the next question. Not next question, we are moving to the next type. So in this we are going to discuss questions which are specifically related to the chemical properties of alkanes, alkenes and alkynes. And I have told you questions are interrelated, so we can also use some concepts of alcohols, we can also use some concepts of aldehydes, ketones, haloalkanes and all, right? That's it. So let's do question number 1. Now if you see this question, in the substrate we have Cl, right? Now Cl can be a leaving group, and leaving group order is going to be iodide is better, then Br, and then Cl. Okay, so this is the leaving group order. And we have NaOH. So NaOH provides OH minus, which is going to be nucleophile. So it means this is simply the question of nucleophilic substitution. Nucleophilic substitution. Now in nucleophilic substitution, we have two parts, SN1 and SN2. So it means we have to check whether we have 1 degree carbocation formation, 2 degree or 3 degree. So see, if Cl leaves, so we have carbocation on to this carbon, which is 2 degree carbocation, right or wrong? So if this is going to be the 2 degree carbocation, then SN1 can happen, SN2 both can happen, right? So SN1 can happen in 3 degree, 2 degree, and here we can say SN2 happen in 1 degree and 2 degree. Now, which factor decides ki whether we are going to proceed the reaction via SN1 pathway or SN2 pathway? So we have to check for solvent. So now here check water. So water OH. So this is polar protic solvent. What is polar protic solvent? Where hydrogen forms bond with more electronegative atom. It forms bond with oxygen, na? That is the more electronegative atom. So it favors SN1. It favors SN1. While polar aprotic solvent, such as DMF, dimethyl formamide, if we have DMSO, DMA, or simply acetone, they favor SN2 reaction, right? So DMF is a dimethyl formamide. So that is this dimethyl formamide. N dimethyl and formamide. It means formic acid is used over here. So this thing is clear that this is the nucleophilic substitution, and which method we have to opt for? We have to opt for SN1. So if we opt for SN1, so it means we have to form the intermediate, right? It's a two-step process. So let's form intermediate. So it means what we can say, we are going to have positive charge over here. Then we have this CH3. Now see, this is 2 degree. We have to check whether we can do rearrangement or not. See, ring expansion though we cannot do, right? Because it is already 6-membered ring, so we cannot do ring expansion. So we can do some kind of shifting. So we have hydrogen over here. If we do shift with this hydrogen, then again we get 2 degree carbocation. Na? Here we get carbocation, right, bete? But if we do shift with this one, so we can get 3 degree carbocation. So this is going to be favored one. So we have to do hydride shift. So by doing hydride shift, this is, suppose this is 1 number carbon and this is 2 number carbon. So hydride shift between 1 and 2. So we get carbocation over here, right? So if we get carbocation over here, so OH minus comes and form bond with this carbocation. So we get this as the answer, right? Point is that if you don't know the reaction, you can do lots of question if reaction mechanism is clear to you. If you know how to proceed SN1, how to proceed SN2, what are the conditions for elimination and all, so you can easily do the question. Okay, so this is my answer. Clear? Very good. Now let's do next question. Next question says nitration of benzene involves the following step. Nitration of benzene. So this is benzene, and in nitration we use concentrated HNO3 beta and concentrated H2SO4, and we get NO2. And this is the part of electrophilic aromatic substitution reaction, right? Electrophilic aromatic substitution reaction. Aromatic substitution reaction. So see, first part, first way, matlab first step is to generate carbocation. Not carbocation, generate electrophile. We have to generate electrophile. So see, what is the role of H2SO4? Eliminate water. To eliminate water. So we are going to do this thing only. So we have H and O3. Okay. And we have H plus and HSO4 minus. ठीक है बेटे? So first what happened? This oxygen takes this H plus, this HSO4 minus leaves, and after that we get N double bond O, OH2 positive and HSO4 minus. Now water becomes a good leaving group, so just remove this. So when you remove this, you get N double bond O and this O carbocation. Water leaves and we have HSO4 minus. Now this is the electrophile that we need. Now what happens? NO2 positive, I can write. So this bond electron, it forms bond with this electrophile. So one of the carbon forms bond with the electrophile and on another one we have carbocation formation. Now this becomes non-aromatic, right? This becomes non-aromatic. So the point is that what we are going to do, acha, aromaticity is lost. We should say aromaticity is lost. Aromaticity is lost. So now in order to maintain the aromaticity, what happens? This HSO4 minus, it takes this hydrogen, right? This hydrogen and electron of this bond shifts over here. So we get nitrobenzene. Understood? So this is going to be the mechanism. So question says, do we have this step? Yes, we have. Use of Lewis base promotes the electrophilic substitution of benzene. Lewis base means electron donor. Electron donor promotes the electrophilic substitution. So, electron donor promotes nothing will happen, because here main thing is we have to generate the electrophile. We have to generate what? We have to generate the electrophile. So, it is incorrect. So, we can say that statement 1 is correct while statement 2 is incorrect. So option B is going to be the correct answer. Clear? Option B is going to be the correct answer. Now let's do next question. So next question. Question says we have alkene. Here we have alkene. Perfect. Now here bond breaks. If you see bond breaks, है ना? Bond breaks. And then we have B region, and here if you see there CH3. So here this bond breaks, है ना? Here we are going to break this bond. How to solve this? How to solve this? See, if you want to dissociate alkene bond, double bond completely. So for example, we have CH3, CH, double bond CH2. If you want to dissociate this bond, so either you can do ozonolysis. So when you do ozonolysis, so just put oxygen over here, oxygen over here. So here we write CH3, C double bond OH or HC double bond OH. Understood? So in that way we can break the bond. So with the ozonolysis, what happened? First ozonolysis and second zinc in the presence of H2O. This is called reductive ozonolysis. Now second thing is that use hot concentrated KMNO4. Hot concentrated KMNO4. So when you break this bond, so here we get carboxylic acid. From here we get carboxylic acid. From here also we get carboxylic acid. So 2 carbon carboxylic acid is ethanoic acid and 1 carbon carboxylic acid is formic acid, which further converts to H2O and CO2. ठीक है बेटे? So point is that here ozonolysis happen. So in ozonolysis, because bond break है ना, bond break, and here we have oxygen. Here we have oxygen and here we have oxygen. See, this carbon is this carbon. So here we have double bond H. So oxygen, oxygen है. So ozonolysis happen. Now ozonolysis we are have in option number 2 or option number D. ठीक है, fine. Now the point is, if you see option 2 is going to be the correct answer, because what happens over here, just try to understand here, double bond, so double bond breaks, right? So we are going to eliminate this thing, and what happens, we have the ozonide formation. And how do we form ozonide? Oxygen, 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 this after O3 reaction. Okay, after O3 reaction we are going to have this one. Now in the presence of ZnH2O we have to break, so just break the bond like this. Okay, now what you need to do, put double bond over here and put double bond over here. ठीक है, यानी double bond over here, double bond over here. So when you do so, you get double bond O and here you have H, and here you get double bond O and here you have CH3. Understood? So we get exactly the same thing. Point is, if you see कि भाई KMNO4 should be the option, तो KMNO4, what will KMNO4? It will oxidize aldehyde to carboxylic acid. So here we have aldehyde group na, aldehyde group. So aldehyde group should be converted to carboxylic acid in the presence of KMNO4. But here we have aldehyde only. Here we have aldehyde only. So this option is incorrect and this option is correct. Now what is NaOH and I2? This is the haloform reaction. Haloform reaction, or we can say iodoform reaction. So what happens in iodoform reaction or haloform reaction? So bete, we should be having this methyl ketones or secondary alcohol. So what happens if you treat this with I2OH minus, or we can say Br2OH minus or X2OH minus, right? ठीक है, so you have to break this bond. This is converted to carboxylic acid salt O minus, and this will give you CHX3. Br2 के साथ we get CHBr3, which is yellow liquid. With I2 we get CHI3, which is the precipitate, yellow in color. So what happens when you dissociate this bond? So you get exactly same thing. ठीक है, clear? Sodium salt of carboxylic acid. So we have Na over here, so we get double bond O minus, and here we can attach sodium. Clarity? So in that way we can do this question. So option D is going to be the correct answer. Okay, now let's do next question. Next question says, in the following given reaction A is, so see, so we have discussed CH3 and here C, let me rewrite. So cyclobutane, we have C, then CH3 and then double bond CH2. We have HBr. So what happens? Markovnikov, we have to do Markovnikov. Nothing is given, sunlight, peroxide, nothing is given. So we have to do Markovnikov. So in Markovnikov, what happens? This double bond, it forms bond with this H plus and Br leaves bete. So we have C, CH3 and here we write CH3 and positive charges formed over here. Up now, you have to check what we are going to do. Obviously, 4-membered ring hai, so we can expand the ring. So this bond can dissociate and the electron of this bond comes over here. So here we have negative charge and here we have positive charge, new positive charge. So if this is 1 number carbon, this is 2 number, this is 3, 4, 5, right? So we get 5-membered ring. So let me write 5-membered ring. So this is 1 number carbon. So 1 number carbon is bonded to 2 methyl groups, CH3 and CH3. Then we have second, 3, 4, 5. On 5th one, we have carbocation formation. Here we have 2-degree carbocation. Up now, if you see this position, here we have methyl group. So if you do methyl shift, so we can generate 3-degree carbocation C. CH3 positive and CH3 over here. ठीक है बेटे? Okay. Now next task, what we are going to do next? We have Br minus. So now Br minus attacks onto this carbon, because now this is 3-degree carbocation. 3-degree carbocation is more stable. So every time you have to check whether we can do rearrangement, whether we can do ring expansion or not. You have to check it. If you are doing SN1 reaction, or if you are making, yeah, if you are forming carbocation, then you must check this. So we get CH3, Br, and here we write CH3. ठीक है बेटे? So as per this, which option is correct? Option 4 is the correct answer. Clear? Option 4 is the correct answer. Now let's do next question. Find out the major products from the following reactions. So we have this. ठीक है? So first is BH3, THF, H2O2 and OH minus. So this is hydroboration oxidation reaction, right? HBO. So here we can form alcohol from alkene, and here we have to do anti-Markovnikov addition. Anti-Markovnikov addition. Anti-Markovnikov addition means negative adenum. Negative adenum. In this case, it is OH minus, right? Goes to that carbon which has more hydrogen atom. So it means we have to check over here. Yes, we have to check over here. So if you see this carefully, so we have 2 hydrogen over here, and here we have only 1 hydrogen. So it means OH minus goes to this carbon. So if OH minus goes to this carbon, so we have this. This is going to be the product. So this is option number A. Now check option number A. So if we see, we can have option number 1 and option number 4. Right. Now we have to check next reaction. So HgOAc whole 2. Right. HgOAc whole 2, H2O and NaBH4. This is oxymercuration demercuration reaction. So OMDM, oxymercuration, demercuration reaction is also used to convert alkene to alcohol. But here we have to follow Markovnikov addition without rearrangement. Understood? Markovnikov without rearrangement. It means negative adenum. In this case, water is there, so we have OH minus goes to that carbon across double bond which has less number of hydrogen atom. Okay, so here we get this, here we write OH. Okay, so if you see this option, or this is B, so option A is going to be the correct answer. Check it. Right? Option A is going to be the correct answer. Okay, is it clear? Here one more thing which you need to memorize. Here we have anti-addition. Because first what will happen, suppose we have a ring CH3 CH double bond CH2 in the presence of HgOAc whole 2, right? We have this formation. CH2, we have this ring formation. Understood? So now what happens? OH minus attacks on this carbon, and this is going to break, which will further reacts with NaBH4, converts to hydrogen, right? Or in presence of NaBH4, this is going to reduce. Clear? So that's a part of OMDM. Now Let's do next question. So the major product P for the following sequence of reactions. So we have pH, double bond this, then this, double bond this, and NH2. So see Zn, Hg, and HCl. This is what? Clemmensen reduction. So Clemmensen reagent, it means it reduces carbonyl compound to alkane. So carbonyl to alkane. So carbonyl means aldehyde and ketone. So this is ketone, this is ketone, and this complete part, that is going to be amide, right? C double bond O NH2, that is amide. So what happens over here? We get pH, H, then double bond O NH2. ठीक है? Now we have LiLH4. So LiLH4 is what? LiLH4 is a reducing agent. Reducing agent. And it reduces all functional groups. Almost all functional groups. So it reduces amide. Amide is this C double bond ONH2 to amines. Amines CH2 NH2. Right? So we get pH, HH or NH2. So here we have 1 carbon, 2, 3, 4, 5 and then phenyl. So if you see 1, 2, 3, 4, 5, so option 3 is the correct answer. Clear, easy question. Now, next question. 17 milligram of hydrocarbon. We have hydrocarbon which is 17 milligram. Molecular formula is C10H16. Takes up hydrogen which is 8.40 ml at 0 degrees Celsius and 760 mm of Hg, which is equal to 1 atm. Yani this is STP, standard temperature and pressure. So ozonolysis of the same hydrocarbon yields this. Ozonolysis of same hydrocarbon yields itna, and we have to find out number of double bonds. Number of double bonds. We have to find number of double bonds. So this is irrelevant to the question, right? This is the concept of mole concept. This is the question of mole concept basically. So see, we know that if we have one double bond, then one double bond consume 1 mole hydrogen. Here we write hydrogen and hydrogen. We remove double bond, but we dissociate pi bond and we will have hydrogen. So suppose this is R and this is R, this is R, this is R. So we can say this is R, R and R. Understood? Okay. So the point is that we just need to find out the number of double bonds in the hydrocarbon. So ozonolysis wala part, it is irrelevant. Right? We can solve the question on the basis of mole concept. So first task is to find out the number of moles of hydrogen. Right? Number of moles of hydrogen. So 8.40 ml. We have 8.40 ml. So we know that 1 mole of any gas at STP, it is equal to 22.4 liter, or we can take 22.7 liter, which is equal to 22400 liter. Bete. We have 8.40 ml na? So we can say 22400 ml milliliter, right? Because 1 liter is equal to 10 to the power 3 ml is equal to 1 mole of hydrogen gas. So 1 ml is equal to 1 by 22400 mole of hydrogen gas. Okay? We have 8.4 ml. So it is equal to 8.4 upon 22400 mole of hydrogen gas. Bete. Okay, bache? On solving this, we get 3.75 into 10 to the power minus 4 mole of hydrogen gas. Okay. Now, next task is to find out the number of moles of hydrocarbon. Okay. So 17 milligram means we have 17 into 10 to the power minus 3 gram. Okay. So C10H16 molar mass is equal to 10 into 12 plus 16 into 1. So 120 plus 16, which is equal to 136 gram. Clear? 136 gram. Up now, number of moles of hydrocarbon. Number of moles of hydrocarbon. That is equal to given mass upon molar mass. Given mass is going to be 17 milligram. So it means 17 into 10 to the power minus 3 gram divided by 136. On solving, we get 0.125 into 10 to the power minus 3 mole, which we can write as 1.25 into 10 to the power minus 3 mole. Okay. Ab now next. 1 mole of, the point is, question says कि इतना मोल ऑफ हाइड्रोकार्बन रिक्वायर्स 8.40 ml ऑफ हाइड्रोजन, राइट? ये तो ना क्वेश्चन इज दिस 17 milligram of a hydrocarbon takes up itna gas. So it means what we can say that ki 1.25 into 10 to the power minus 4 mole of hydrocarbon requires how much? 3.75 into 10 to the power minus 4 mole hydrogen gas na. So 1 mole of hydrocarbon requires 3.75 into 10 to the power minus 4 upon 1.25 into 10 to the power minus 4 mole hydrogen gas, which is equal to 3 mole, which is equal to 3 mole. So if 1 mole of hydrocarbon requires 3 mole of hydrogen gas, it means 3 double bonds must be present in 1 mole of hydrocarbon. So total number of pi bonds, total number of double bonds present in the hydrocarbon, so that is equal to 3. So you have to report answer as 3. Clear? Now let's do next question. The one giving maximum number of isomeric alkenes on dehydrohalogenation reaction. So first of all, dehydrohalogenation means removal of hydrogen from alpha carbon, right? Not halogen from alpha carbon. Removal of hydrogen from beta carbon and removal of functional group, which is the halogen from alpha carbon. From alpha carbon. Because carbon bonded to functional group is the alpha carbon, right? Or carbon bonded to intermediate is the function is alpha carbon. So the point is the one giving maximum number of isomeric alkenes on dehydrohalogenation. So basically you have to exclude rearrangement, and the only way to check is you have to check options. There is no other way to do this question. So if we have first 1 bromo 2 methyl butane. So 1 bromo 2 methyl butane, 1 2 3 4. So on 1 we have bromo, and on second we have methyl. So we have CH2, this is CH, CH2 and CH3. 1 2 3 4. Okay, so this is alpha carbon and this is beta carbon. So we have to remove hydrogen from beta carbon. So hydrohalogenation say it means we have to remove HBr. So we get CH3 CH2 C CH3 double bond C, right? C double bond CH2. Okay, so we get this alkene. We are going to form double bond in between carbon number 1 and carbon number 2. Br is removed and we have to remove this hydrogen. Okay, is it clear? We have to remove this hydrogen. Okay, so we get this one. So we get only one product because we have one beta hydrogen. Now check second one. 2 bromopropane. So 1 2 3. So 2 bromo. So we write CH3 and here we write CH. Okay, so this is alpha carbon which is bonded to functional group. This is beta carbon. So beta 1 and beta 2 are same. Same na? Same. So we will get only one product. And what is going to be product? Just remove hydrogen from beta and remove functional group from the alpha carbon. So we get this as the product. Now check third one. 2-bromopentane. 2-bromopentane means 1, 2, 3, 4, 5. So 2-bromo. Now CH3, CH, CH2, CH2, CH3. ठीक है बेटे. अब now we have 2 beta hydrogen. See, this is beta 1, this is alpha carbon, and this is beta 2 carbon. Now beta 1 and beta 2 are different. So if beta 1 and beta 2 they are different, so we get 2 alkenes. First, if you remove beta 1 hydrogen, so we get CH2 double bond CH, CH2, CH2, CH3. And second, if you remove beta 2 hydrogen, so you get CH3, CH, double bond CH, CH2, CH3. If you remove beta 2 hydrogen, you will get double bond over here. And if you remove beta 1 hydrogen, you will get double bond over here. Because dehydrohalogenation is the kind of elimination reaction which is known as the beta elimination. Okay, now check fourth one. 2-bromo-3,3-dimethyl pentane. So this is fourth one. 1, 2, 3, 4, 5. So 2-bromo-3,3-dimethyl pentane. So CH3, CH2, CH3. So see, alpha carbon beta. Only one beta carbon is there. So if one beta carbon is there, one beta carbon is there, so one beta hydrogen. So it means here also we get one product. So the one giving maximum number of isomeric alkanes on dehydrohalogenation, that is going to be option number 3. Isomeric also, it means we have to check cis and trans. So see, here so we have two hydrogen na, on same side like CHH. So no cis and trans. But if you check this option, so here we have cis and trans. Here we have cis and trans. How to form cis? CH3, CH, double bond CH, and then CH2, CH3. So this is the cis form, right? That is the cis form. Now, what is the trans form of this one? So CH3, CH, double bond CH, and this is CH3. So that's a trans form. This is the cis form. This is the trans. So total number of products that we get from option number 3 is 3. 3. If you see hydrogen on the same side, so no cis and trans. No cis and trans. ठीक है बेटे? If you see this option, again hydrogen on the same side, so no cis and trans. No cis and trans. In this option also, no cis and trans. So 3 products we are going to get from option number 3. So option 3 is the answer. Okay. Now let's do next question. The major products A and B respectively. So we have CH3, CH3, double bond CH2. So first is the cold H2SO4. Cold H2SO4 means we have, we can say H plus and HSO4 minus. HSO4 minus is this. As double bond O, OH and O minus. This is HSO4 minus. So in cold H2SO4, elimination won't happen. Elimination won't happen. We are going to do nucleophilic substitution because condition is cold. Elimination happens if you provide heat energy. So what happens? Obviously, we have to follow Markovnikov rule. Markovnikov rule. So general is Markovnikov rule. Anti-Markovnikov rule we have to follow if we have HBr. It means anti-Markovnikov. Anti-Markovnikov we have to follow if we have HBr, sunlight, UV light, peroxide and extreme heat. ठीक है? So Markovnikov, so it means negative adenum goes to this carbon. So we get CH3, COSO3H, CH3, and here we write CH3. So this is option number A. Option number A is this. So if you see, we can have option number 1 and option number 4. Now we have to check second one. So if you see option number 1 and option number 4, right? So in the product, we will have, here we have 4 carbon, and in the product 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It means something else is happening. Because for the elimination, temperature should be high. Temperature should be high to form alkene. So what we are going to do over here? What will happen over here? Okay, so see, in second case, we have this CH3, C, CH3 and double bond CH2 beta. Okay, CH2. So, see, we have HSO4 H plus and HSO4 minus. So, double bond reacts over here, double bond H plus. So, CH3, C, CH3 positive, and we write CH3. Also, it is alkene, so we cannot have elimination reaction, right? So, something else is going to happen. So, this is a carbocation. So, now double hai, if carbon atoms are double, so we have to think, oh, it means we have to take 2 molecules of this, right? So, one molecule is this, first molecule is this, and second molecule is this. Now, what will happen? This is already 3-degree carbocation. So, this double bond attacks on this carbon. So, by doing so, we get CH3, C, CH3. Here we write positive, right? Positive, and we write CH2, C, CH3, CH3 and CH3. Up next, HSO4 minus 70 degree Celsius है. अब what is going to happen? We do not have any other situation, right? So what will happen? We are going to remove C. This is beta carbon, na? This is beta. Okay, so we have beta hydrogen over here. So we have two types. This is beta 1, and this is beta 2. So in order to get ZZF alkene, we have to remove beta 2 hydrogen. So CH2, let me write it like this. So HSO4 minus takes this hydrogen and electron of this bond shifts over here in order to satisfy carbocation. So we have to remove beta 2 hydrogen to get ZZF product. To get ZZF product. Now we get CH3, C, CH3, double bond CH, C, CH3, CH3 and CH3. Clear? So it means option A is going to be the correct answer. Clear? Now let's do next question. Choose a correct set of regions for the following conversion. So we have trans this pH, CH, double bond CH and CH3. Right? So we have what? pH, CH, double bond CH, and this is what? CH3. So this is the transform. Why this is the transform? Because hydrogen, they are on opposite side. And we have to form cis form. Cis double bond C, H, H, pH, and CH3. So hydrogen, same side across the double bond. So this is going to be the cis form, right? Up now, how to solve? If you see the regions, right? If you see the regions, so what happens? What is the role of alcoholic KOH or NaNH2? Dehydrohalogenation. Or we can say elimination reaction. And if I say elimination reaction, yani alkene is going to be the product, right? Alkene is going to be the product. Now what is the role of Br2? Br2 adds across the double bond or unsaturation. So if we have the triple bond, then Br2 is going to add like this. But that's the anti-addition, not same side, anti-addition. Okay? Why anti-addition? Because see, if we have double bond, let me take the example of double bond. So this is double bond. Here we write some R, here we write H, here we write H, and here we write some R2. So Br2. So what happens? The electron of this forms bond with this one, and then this dissociate. We have lone pair on bromine, right? 3. So it forms bond with this, because we will have the development of positive charge on this carbocation. So if I say carbocation, so carbocation means empty orbital. So we have R, C, C, Br positive, then H, H and R. Now Br minus is going to add on this carbon, and electron of this bond dissociate, or this bond breaks. So we get R, C, H, C. Here we write Br over here, and here Br is over here below the plane. Understood? So in that way we have to do. So how to solve this? So cis, we want cis alkene. So we have Lindlar's catalyst. So Lindlar's catalyst is used to form cis alkene. Cis alkene, right? Cis alkene. So see how to solve this. So first what we are going to do, Br2. So Br2 says C, Br, or let me write it Br, Br, then H, CH3, then phenyl, and this is H. Okay. Now we have what? Alcoholic KOH. Alcoholic KOH, OH minus, it takes hydrogen, right? And electron of this bond shifts over here, and Br leaves. Dehydrohalogenation. So this is the elimination reaction. So we get C, H, double bond C, Br, and CH3. Now next we have NaNH2. NaNH2. So NH2 negative. So NH2 negative, this hydrogen. Okay. So electron of this bond shifts over here, and Br leaves. So this is also the part of elimination. So we get phenyl, C, triple bond C, and CH3. So we get alkyne. Now we have to convert alkyne to alkene. So from alkyne to alkene, we have two regions. One is Na in the presence of liquid NH3. So it will give us transalkene. It gives us transalkenes. And if we use H2 in the presence of palladium, which is the Lindlar's catalyst, so we get cisalkene. Okay, we get cisalkene. Even we can use H2. We can use H2PD carbon, or we can say charcoal, H2PD CaCO3. We can use H2PD BaSO4. So from all these regions we get cisalkene from alkyne. Clear? That's it. So answer is going to be option number B. Okay. Here we have aqueous KOH. If you see, we have aqueous KOH. Aqueous KOH, it shows nucleophilic substitution, not elimination reaction. But here is the need to eliminate the hydrogen and halogen, which is bromine. Now let's do this question. We have hydrocarbon X. With molecular formula C6H8 uses 2 moles of hydrogen. 2 moles of hydrogen on catalytic hydrogenation of its 1 mole. It means the point is कि 1 mole hydrocarbon requires 2 moles of hydrogen. So 2 moles of hydrogen means we must have 2 double bonds ना, 2 double bonds. That's why 2 moles of hydrogen is required. ठीक है बेटे? On ozonolysis, X yields 2 moles of methane dicarbonaldehyde. On ozonolysis, X yields 2 moles of methane dicarbonaldehyde. So methane is this. If I say dicarbonaldehyde, so it means CH2. Here we write CHO, and here we write CHO. Or I can also write in this way. C double bond OH. So we get 2 moles na. So C double bond OH, CH2, C double bond OH. Now how to form alkene, right? So there is a trick. There is a trick. What you need to do, just remove this, right? Remove oxygen and form double bond. So it means this is basically we are doing backward reaction, right? So here we write HC double bond CH, then we have CH2, then C double bond C, here we have H, here we H. So what is the name of this compound? This is going to be cyclohexa 1,4-diene, है ना? This is going to be cyclohexa 1,4-diene. Here we have seen, na? So cyclohexa 1,4-diene. Clear? Cyclohexa 1,4-diene. ठीक है बेटे? So answer is option number 4. Clear? Now let's do next question. Number of bromo derivatives obtained on treating ethane with excess of Br2. Ethane, CH3CH3, Br2 excess in diffuse sunlight, H nu, or we can say sunlight. It means we have to form free radical, na? Free radical. So देखो, free radical. First तो we are going to form this free radical, CH3CH2 radical. Right? We can form this radical. We can also form this radical, ना? अब जैसे CH radical बना, CH2 radical. So we can form this compound CH3CH2Br. Now again what we can do? Another free radical we can form. So CH3, CH radical and Br. So from this we can form CH3, CH, Br and Br. Right? Up this is monobromo derivative. Monobromo derivative. This is dibromo derivative. So we have different ways to write all the products. So see, we have monobromo derivative like this, CH3, CH2Br. That's the only possible way. Now dibromo derivative, we can write CH3, CH, Br, or what we can write CH2Br or CH2Br. Then we have tribromo derivative, so CH3, CH, Br, or we can write C, Br, because that is in excess, right? This is tribromo. Or we can write CH2Br or CH, Br. So tribromo derivative. Now we can have tetrabromo derivative. How? CH2Br, Br. Or we can write CH, Br. Understood? So that is tetrabromo derivative. So then we have pentabromo derivative. Penta, CH, and then Br, or here we write Br. That is a pentabromo derivative. Similarly, we can form hexabromo derivative. So hexabromo derivative like Br, Br. All the hydrogen, they are getting replaced with the bromine. So total number of bromo derivatives, how many? 1, or we can say 1, 2, 3, 4, 5, 6, 7, 8, 9. So total bromo derivatives, they are going to be 9. So answer is 9. Clear? That's it. Now let's do next question. Molar mass of hydrocarbon X, which on ozonolysis consumes 1 mole of O3 per mole and gives 1 mole each of ethanol and propanol. 1 mole. Ethanol is CH3, C double bond OH, and propanol is C double bond O, CH3 and CH3. There's a way why I'm writing this, right? Propanol is this and ethanol is this. and we have to find out molar mass of X. So see, we get ethanol and one. It means aldehyde and ketone. So this is the part of reductive ozonolysis. Reductive ozonolysis. So basically we have two types of ozonolysis. One is reductive and second is oxidative. So in reductive ozonolysis, first O3 and then second ZnH2O, or we can say dimethyl sulfide. So that do reductive ozonolysis, and reductive ozonolysis products, they are going to be either aldehyde or ketone. Okay. Now oxidative ozonolysis, we write O3, water or H2O2. And what are the products of oxidative ozonolysis? Aldehyde is converted to carboxylic acid while ketone remains ketone. Understood? So these are the products of oxidative ozonolysis. So see, we have to find out first what? X, hydrocarbon. So what we need to do? Remove oxygen and put double bond. There is a trick. Remove oxygen, put double bond. So we get CH3, CH, double bond C, CH3 and CH3. So this is the hydrocarbon that we get. Now we can calculate molar mass. How? We have 1, 2, 3, 4, 5. 5 carbon, so yani 5 into 12. Total hydrogen 3, 4, 5, 6, 7, 8, 9, 10. So 10 into 1, right? So 12 5 is 60. 60 plus 10, that is equal to 70 gram. Right? So answer is going to be 70. Easy question. Very easy question. Now let's do next question. The major product P formed in the given reaction is P. Alkaline KMNO4 and heat. So see, there is, if we have benzene and here we have carbon and hydrogen hai, and that carbon, अब now it can form bond with hydrogen, carbon, oxygen, whatever, double bond, whatever. If you take alkaline KMNO4 and heat it, so whole part is converted to carboxylic acid. What should be the condition? This carbon should be bonded to hydrogen, at least one hydrogen. This should form bond with at least one hydrogen. That is the major thing. So now see, here we have this situation. This carbon is bonded to hydrogen. Here we have this situation. And here we have also this situation. See, C, H and H. So what happens? Everything is converted to COH. So what do we get? We get COH, COH and COH. Very easy question, no? Very easy question. So everything is converted to COH. So answer is going to be option number this. That is 2 basically. Clear? We cannot have CH to COH. No way. Everything is converted to this. It means suppose we have this CH to CH3. Alkaline KMNO4. We get COH. Okay, bete. If we have CH2, CH double bond CH2, same. Everything. Condition should be this carbon is bonded to hydrogen. Okay. Now, next question. The two products formed in the above reaction are. So see, if you see reaction, we have hexene, alkene. 2 hexene. It means 1, 2, double bond, 3, 4, 5, 6. This is the situation. O3 and second is H2O. H2O means oxidative ozonolysis. Oxidative ozonolysis. So what do you need to do? I have already discussed the mechanism in the above question. Here I am going to use a trick only. It just dissociate this bond. Here put double bond O and here put double bond O with this carbon. So we get CH3C double bond O H. Right? Then we get CH3, CH2, CH2, C double bond OH, because 4 carbon है ना, तो 4 carbon aldehyde, but we have water. So aldehyde part is converted to carboxylic acid. So we get CH3COOH, 2 carbon carboxylic acid, right? And here also 4 carbon carboxylic acid, which is butanoic acid. So we get acetic acid and butanoic acid. Simple question, right? So we get option number 4 as the answer. Clear? Now moving on to the next question. Let's do it. ठीक है जी. Let me write this completely. It is slightly blurred. So question is CH3 CH double bond CH2. First is B2H6 H2O2 NaOH. This is what? Hydroboration oxidation. And what is the use of this? Alkene to alcohol, but by anti-Markovnikov addition. By anti-Markovnikov addition. ठीक है बेटे? So we get CH3 CH double bond CH2. So if you use B2H6, right, then H2O2 or OH minus. So we get CH3 CH2 CH2OH. It means OH minus goes to that carbon which has more number of hydrogen atom, that is anti-Markovnikov. Now next, PCC. PCC is what? Pyridinium chlorochromate, right? It's a mild oxidizing agent. So it converts aldehyde to, or sorry, alcohol to aldehyde. Carbon atoms remain same. So we have 3 carbon alcohol, so we get 3 carbon aldehyde. ठीक है? Now next part. CH3MgBr. CH3MgBr. Now CH3MgBr. So what is the role of this? So this is a base. So in presence of acid, it abstract hydrogen. But here we do not have any acid, so it shows nucleophilic addition. So C double bond O, this bond is polar, delta positive, delta negative. Here magnesium is delta positive, carbon is delta negative. Why? Because magnesium is a metal, it is electropositive, while CH3 delta negative. So CH3 takes these 2 electrons and attacks on this carbon and carbon. The electron of this bond shifts to oxygen, and oxygen forms bond with Mg. So we have CH3 CH2 C CH3 H and OMGBr. ठीक है? So this is the situation. Now we have to hydrolysis. We have to do the hydrolysis. Here it is not given, but if you see the option, we get OH, OH, OH. We do not have MgBr. It means we have to understand. It means after this we have hydrolysis. This should be given. It is not given, but we have to understand the situation by looking the options. So on hydrolysis, what happens? We have to dissociate that bond which has high electronegativity difference. So here the bond which is present between metal and non-metal, high electronegativity difference. Na? Here delta En is high. Oxygen delta negative, magnesium delta positive. So here we write OH and here we write H. H positive. वही है ना? Negative goes to positive. So we get CH3 CH2 CH3 OH. ठीक है बेटे? Plus MgBr OH. Now if you see the option, which option is the correct one which matches with this? So option 3 is going to be the correct answer, right? That is going to match with option number 3. Okay. Now moving on to the next question. Which of the following compounds produces an optically inactive compound on hydrogenation? Optically inactive compound. So see, first so hydrogenation. If you do the hydrogenation of first one, so you get this. Hydrogen here, CH3 here. ठीक है? If you do hydrogenation of second one, so you get this one. If you do hydrogenation of third one, so you get this one. Across double bond, you have to add hydrogen. And if you do the hydrogenation of fourth one, you get this one. ठीक है? So question says optically inactive. Optically inactive means where plane of symmetry optically inactive, where plane of symmetry is present or center of symmetry is present or axis of symmetry is present. So it means those compounds are optically inactive. So if you, matlab, what is plane of symmetry? It means you have to imagine the plane which cuts the molecule into two equal halves, right? What is plane of symmetry? Imaginary plane, imaginary plane which cuts the molecule into two equal halves. ठीक है? So if you see this plane here, ठीक है? This is a plane which passes which that plane cuts hydrogen, methyl and this carbon. ठीक है बेटे? This carbon. So if this is going to be the plane, that plane, एक मिनट, we can say this should be the plane. So it cuts the molecule into two equal halves. See, we have same isopropyl and here also isopropyl. So it cuts the molecule into two equal halves. See, if this is a plane, then it cuts the molecule into two equal halves. So this is going to be optically inactive. So answer is fourth. Let's say if we see option number 2, if the plane is this, right? If the plane is this. So here we have this group beta and here we have this group, right? So we have different group, no? We have different group. So different groups, different groups. So plane of symmetry is absent. So that is optically active. Clear? So option 4 is going to be the answer. Now let's do next question. Which of the following is Lindlar's catalyst? H2 in the presence of palladium, carbon, charcoal. So fourth, right? Fourth option. Very easy question. Clear? Let's do next question. The major product of the following addition reactions. Addition है. तो Cl2 plus H2O, it gives beta HOCl plus HCl. याद रखना है. Learn it. HOCl and HCl. Now, if we see oxygen and chlorine, so oxygen is more electronegative than chlorine. So it means we write OH minus and Cl positive. Clear? अब addition reaction है तो we have to do Markovnikov only. Markovnikov. ठीक है? CH3 CH double bond CH2. So we have Cl positive and OH minus, है ना? HOCl basically. So what we can say that I can write in that way HOCl. So double bond takes Cl and we have this one, right, bete? So CH3 CH CH2 and then Cl positive, because chlorine has lone pair, carbocation has empty orbital, so we have the bond formation, so we have the chloronium ion formation. So again this is going to be the anti-attack. So OH minus attacks on this carbon and this bond dissociates. So if this bond dissociates, so we get CH3CHOH and here we write CH2Cl. Clear? So what is the answer? CH3CHOH and CH2Cl. So option 1 and 2 both are correct basically, है ना? All both the options are same, right? So 1 and 2, right? Same. That's the error in the question. but don't worry, we have understood the concept, right? Next. ठीक है, now this is very important concept. This is not the part of mains, but I would like to discuss this concept with you. So see, we have cis. अब now Br2 addition already discussed. This is going to be anti addition. ठीक है, so here options na options can be given in terms of Fisher projection. So you have to learn cat. C for cis, A for anti addition, and T means 3O. 3O means जैसे बी आर है तो बी आर इज गोइंग टू बी ऑन अपोजिट साइड. यू हैव टू एड बी आर ना, तो बी आर इज गोइंग टू बी ऑन अपोजिट साइड. दैट्स हाउ वी फॉर्म फिशर वन. So here we write CH3, here we write CH3, this is H and this is H. So this is the 3O form. ठीक है बेटे, तो cis anti 3O, तो we write CH3 as it is, CH3 as it is, Br over here, Br over here. So in the 3O form. So this is going to be the answer. If this is not given, so it just you can show, because anti addition hai na. So if one Br is over here, so you can write another Br over here. ठीक है, another Br over here. Clear? ठीक है बेटे, that's it. If that is not given, अब the point is, but you have to learn this because this is the trick, right? So cat, if we have say cat, but in place of anti addition we have sin addition. Sin means addition from same side, so we get E means erythro. What is erythro? Like Br on same side. ठीक है, is it clear? So just you have to learn cat, उससे you can solve the question. जैसे we have trans Br2 anti addition, you should know कि whether we have anti addition or sin addition or not. तो trans anti, so see cat, cis anti 3O, so it means trans anti erythro. So we get CH3, HBr and HBr. That's the erythro form. Understood? And if we have trans sin, so if it is sin, so we get T, yani 3O form. 3O form we know that if Br hai, so that is going to be on different side. Clear? Is it clear? So in that way you can learn. So answer is this. Okay. Now moving on to the next question. Which of the following alkenes when treated with HCl yields majorly an anti-Markovnikov product? Anti-Markovnikov product means negative adenum goes to that carbon across double bond which has more hydrogen atom. ठीक है, so basically in the Markovnikov, if we see in the Markovnikov, we have to form carbocation. So where carbocation is unstable, so there we have to form anti-Markovnikov product, right? Anti-Markovnikov product. So see, first option OCH3. So OCH3, so we have CH double bond CH2. So if I form carbocation, so OCH3, so we have CH positive and this is CH3. This is as per Markovnikov. ठीक है. Now in second option, Cl CH double bond CH2. So again we get Cl CH positive CH3. Now in third, H2N CH double bond CH2. So we have H2N CH positive CH3. Then in fourth option, we have CF3 CH double bond CH2. So CF3 CH positive CH3. The point is we have to find out where carbocation is highly unstable. So see, this is the electron releasing group. तो इलेक्ट्रॉन रिलीजिंग ग्रुप स्टेबिलाइज कार्बोकेटाइन. ठीक है, स्टेबिलाइज कार्बोकेटाइन. Here we have Cl, so withdraws. So here we have minus I. So destabilize carbocation. Here NH2 lone pair, so again electron releasing group. So stabilize carbocation. Here CF3, more electronegative, na? More electronegative. So it pulls electron more, right? So more electron withdrawing. So destabilize carbocation to greater extent. So here, because fluorine is highest electronegative atom, so here we have to take option number 4. It means it is going to yield an anti-Markovnikov product, not Markovnikov. Clear? Now let's do next question. So we have this situation. What? The major product formed in the following reaction. HBr है, double bond है, it means just follow Markovnikov rule. Markovnikov rule में you have to form carbocation, so you have to check whether you have to do rearrangement or not. ठीक है? So see, CH3, CH, double bond, CH and then CH and then CH3 and CH3. So if you react this with HBr, no free radical, because if we have to do free radical mechanism, then sunlight, peroxide, it should be given. So this forms bond with H plus, Br leaves. So we get CH3CH. अब now where carbocation is more stable? Obviously we have to form carbocation over here. करना पड़ेगा. Because then after shifting we get the more stable carbocation. So here CH2 and here CH positive, CH, CH3 and CH3. So now what we are going to do? This is 2 degree carbocation. So see na, we can do hydride shift. So just do hydride shift. So after doing hydride shift, bete, so we get CH3, CH2, CH2. Here we get positive. CH3 and CH3. So this is 3 degree carbocation, which is more stable. And if 3 degree carbocation is more stable, so we get carbocation over here, right? Ab now Br minus. So Br minus forms bond with this carbon. So we get CH3, CH2, CH2, CBr, CH3 and CH3. So this is called SN1 rearrangement product. Okay, SN1 rearrangement product. Acha, hydride shift is faster than methyl shift because lighter element. So it can easily shift from one carbon to another carbon. ठीक है? So we get answer. We get answer equal to option number 4th. It matches with 4. CH3, CH2, CH2. So CH3, CH2, CH2. Then CBr, CBr, and then CH3 and CH3. ठीक है? Option 4 is going to be the correct answer. Moving on to the next question. Again, what is a major product formed by HI? See, HI, double bond. It means Markovnikov. You have to check whether we can form rearrangement or not. So just check the CH3. See, let me write on next page, bete. So we have CH3, C, CH3, CH3, then C, H, double bond CH2. So we have HI. So same thing. This double bond forms bond with H plus and I leaves. I minus leaves, right? So iodine leaves as I minus. So CH3, CH3, we get CH positive, and here we write CH2. 2 degree carbocation. But if you see, we have methyl, right? So here methyl shift is going to happen. So after methyl shift, what happens? CH3, C, CH3, we write positive over here, and then CH3, एक मिनट, just wait. We write CH, CH3 and CH3. 3 degree carbocation. Ab now I minus attacks on this carbocation. So we get CH3, CCH3, I, then CH, CH3 and CH3. ठीक है? So if you see this, so option third is going to be the correct answer. ठीक है? Option third is going to be the correct answer. Now moving on to the next question. The major product of the following reaction. Again say triple bond है, but we have DCl. So CH3C triple bond CH. What is DCl? Hydrogen which has mass equal to 2. So that is deuterium, right? So one equivalent. So we can say DCl, but one equivalent only, yani one part. So first thing, one is going to form bond with D and Cl leaves as Cl minus. So we get CH3 C positive double bond CHD. ठीक है? Now we have Cl minus. We cannot do any kind of shift. It is not possible over here, right? So we get 2 degree carbocation. So Cl minus attacks over here. So we have CH3 CCl double bond CH and D. ठीक है? Next we have Di situation. Next we have Di situation. So CH3 C Cl double bond CHD. So again we have Di. We have to follow Markovnikov. We have to follow Markovnikov. So it means this double bond forms bond with D plus and iodine leaves as I minus. So we get CH3 C positive beta Cl and CH D. ठीक है? 2. अब now I minus. So I minus is going to attack on this one. So CH3 Ci Cl and C, not CH to D, here we also write D, है ना? Because H is not there. So D and here D. So here we write CH D2. We get geminal dihalide. That's a situation. We get geminal dihalide. Geminal dihalide. Okay. So geminal dihalide. So we have answer equal to option number 4. Clear or not? ठीक है? Now moving on to the next question. This is one of the concept that I would like to the next question. This is one of the concept that I would like to discuss with you. So this is important. So let's do this question. So what is the question? We have double bond. We have double bond and triple bond, but not in conjugation. But not in conjugation. ठीक है? It means delocalization is not there. So here double bond is more reactive than triple bond. Why? See, double bond is more reactive than triple bond. Why? Because if double bond reacts, so we have CH3 and CH positive, CH2 C triple bond CH, right? If double bond reacts, and if triple bond reacts, then we have CH2 double bond CH and then CH2 and then C positive double bond CH2. Here positive charge is on double bond, so it is unstable in comparison to this one, right? So we get product from this one. So double bond is more reactive, we get product from this one. So here what do we get? CH2 CHCl or CH2H we can write. So CH2C triple bond CH, right? And if we do the numbering, so that is from the left hand side, double bond. If double bond and triple bond they are on equivalent position, then we have to do numbering from the double bond side. Okay, so here we get 1 2 addition product. Here we get what? 1 2 addition product. Okay, that's the case. If double bond and triple bond they are not in conjugation. If we have double bond and triple bond are in conjugation, 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 it means we can move like this, na? It can move like this, right? हो सकता है, it is possible. So we get 1,4 addition product. We get 1,4 addition product. We get 1,4 addition product. So actual what happens? So here triple bond is more reactive than double bond. Why? Triple bond is more reactive than double bond. Why? See, if we react on triple bond, so we get carbocation formation over here and we get CH2. But this carbocation is stabilized by resonance. Stabilized by resonance. See, we get this. ठीक है बेटे? So here we get CH2 positive, CH double bond C, right? So we have this, and then this bond should shift over here. So we have this. So we can have the resonating structure, or we can also say that this is going to be the allylic carbocation. है ना? Allylic carbocation. Why? Because this next carbon is sp2 hybridized. Right? Next carbon is sp2 hybridized. So this is resonance stabilized. That's why what do we get over here? We get CH2 double bond CH and Cl double bond CH2. Understood? So see, in the product also we have conjugation, right? We have conjugation. So conjugation means more stable product, right? More stable product. That's it. Okay. So let's do this question. The major product in the following reaction is this. So how to do this? So again H2O H plus beta. So we have to do Marconi curve, right? We have to do Marconi curve. So what do we get? We get CH3 over here, and here we get CH positive, and here we write CH3. So we have to see whether we can do rearrangement or not. So if you see, we have 5-membered ring now, so we will do rearrangement. So here we get new positive charge generation. So we get CH3 over here. Okay, that's a 6-membered ring we have to form now. 6-membered ring we have to form. So we get, this is 1 number carbon, this is 2, this is 3, this is 4, this is 5, this is 6. So this is 2 number, and 1 number carbon is also bonded to CH3. On 2 number carbon we have carbocation, new generation, right? Okay, now H2 positive heating hai. So we have hydrogen over here. So hydrogen bond electron, it shifts over here. So we have this product, right? We have this product. Now if we see the option number 2 is the correct answer, right? Now let's do the next question. The major product obtained from the following reaction. Hg2H plus H2O. It means what? We have to follow Marconi curve, addition, and this reaction is the part of Kucherov reaction. Kucherov reaction. Hydration of alkynes. ठीक है? So अब see, let me write this. So we have this benzene, this is NO2, and this is electron withdrawing group. We have C triple bond C, I guess. Yeah. And then we have this benzene ring which is connected to OCH3. So it has lone pair. So this is electron releasing group. Now what happens? Same situation is going to happen. So first is H plus. So one bond is going to attack on H plus. So we have two situation now. Two situation. So we have the positive charge formation over this carbon. Why? Because we have electron releasing group over here. So this electron releasing group stabilize carbocation, right? We cannot have positive charge generation on this carbon. Carbocation cannot be formed because here we have electron withdrawing group. Okay, so we have this situation. Now OH minus forms bond with this. So we have NO2 over here, then CH double bond COH, and here we write OCH3. Now how to check this? This is enol form, OH and double bond. This is enol form. Now enol form is converted to keto form, है ना? Enol form is converted to keto form. So how to form keto? मतलब how to form this? So see, this bond electron comes over here, right? This bond electron comes over here because we get C double bond OH, na? Or we can write in that way, we get this one, NO2 C H2 C double bond O and then this OCH3. ठीक है बेटे? Is it clear? That's it. Okay, that's it. And if you want, so first what is going to be the answer? So the answer is going to be option number क्या है? Double bond this OCH3. So option number 1 is going to be the answer. ठीक है? CH2 C double bond of this. अच्छा, see. अब now how to form tautomers? See, what we can say, we have this bond. ठीक है? So this bond shifts over here. This bond electron goes over here, so negative charge, na? So this can take this hydrogen. So in the tautomerization, hydrogen shift happens. Tautomerization means adjacent hydrogen shift. Adjacent hydrogen shift. Clear? That's it. Option 1 is the answer. Now let's do next question. The major product of the following reaction is. So again, HBr. HBr, so see. Here we have minus I effect because in case of halogen, inductive effect dominates. And this is the electron withdrawing group. So here this is electron withdrawing group, right? Double bond to one. So see, we can say this is Cl. Okay, Cl over here. And we have Br, right? HBr here. So we can say carbocation forms over here. And here we write hydrogen. This is going to be double bond. Clear? This is going to be the double bond. Ab now what happens? If we have Br minus, so Br minus attacks on this carbocation. So we have Cl, this is Br. ठीक है? Cl Br and this is double bond O. Ab now we have one more situation, right? We have one more situation. We can have carbocation over here also. Positive over here. ठीक है? And this is double bond O. Clarity or not? We can have this situation. ठीक है बेटे? So then Br minus can attack over here and we get this Cl and Br and this is going to be double bond O. Which is more stable? This is more stable or this is more stable? Batao, tell me which is more stable. So this is one carbon which is bonded to oxygen. Here carbon which is bonded to chlorine. So which one is more electronegative? Oxygen is more electronegative, so it withdraws more. This part withdraws more, right? Withdraws more. So it means we can form this. Clear? Clarity? Now next, double bond Cl and Br. We have alcoholic KOH. So alcoholic KOH role is removal of HX. So here we have hydrogen, here we have hydrogen, right? So OH minus takes this hydrogen, electron of this bond shifts over here and Br leaves. Similarly, in the next step, what happens? OH minus, right? OH minus takes this hydrogen, electron of this bond shifts over here and chlorine leaves. Right, bete? So we get this double bond O. Right? Double bond O. Now what we are going to do over here? Now, what is the main thing? Can we do this thing or not? Yes, we can do this thing. Next, this is not aromatic. So what we are going to do? This is H. This is H. So this is the keto form. We are going to convert this into enol form so that it can be converted into the aromatic compound. So what happens? What happens over here? This bond This bond shifts over here. So O minus, it takes this hydrogen and electron of this bond shifts over here. So we get phenol, right? We get phenol. So answer 2 is going to be the correct answer. ठीक है? ठीक है? Answer 2 is going to be the correct answer. ठीक है? That is going to be the major product. अच्छा, अब now we have the situation ना कि we can only form one double bond, मतलब one single bond. We can form this one. जैसे we can form this one. Here, if we attack Br, because Br is a good leaving group ना, Br good leaving group in comparison to Cl. So we should be having this one, bete, double bond here and this Cl. We should be having this one. Do we have this kind of product? No, we don't have. We do not have this product, right? So that's why we have to look for another option. Okay, that's why we are taking alcoholic KOH in excess and we are going to form phenol because this is going to be aromatic also. Okay, aromatic. So answer 2 is going to be the correct option, right? Option 2 is going to be the correct answer. Now let's do next question. The major product of the following reactions. See, Br. Dehydrohalogenation. So CH3, CH2, CHBr, CHHBr. ठीक है? So what happens in the first step? Alcoholic KOH, it takes one of the hydrogen electron of this bond shifts over here and Br leaves. So we have CH3, CH2, CH double bond CHBr. Or I should write it like this. CH. Now next. NaNH2. So NH2 minus. Right, bete? So it takes this hydrogen electron of this bond shifts over here and Br leaves. So we get CH3, CH2, C triple bond CH. So option 4 is going to be the correct answer. Clear or not? Option 4 is going to be the correct answer. That's it. Now let's do next question, bete. Let's do next question. So we have this one. ठीक है. Identify the reagent and condition for the reaction. So see, if you see the reactant, we have alkene and we have Cl over here, right? So it means we have allylic substitution. Yani this position, that is allylic position. And what is allylic position? What is allylic position? Position, right? That position where adjacent carbon is sp2 hybridized, right? Position of carbon which is bonded to sp2 hybrid carbon. ठीक है बेटे? So that's allylic substitution. So allylic substitution is specifically if we want allylic substitution na, so that happens via free radical mechanism. Free radical mechanism. And for free radical mechanism we have condition the sunlight and all. ठीक है? And chlorine substitution है. So it means we can say Cl2 in the presence of UV light. Cl2 in the presence of UV light. Clear? So answer is going to be third one. Answer is going to be the third one. Clear? Now let's do next question. The major product of the following reactions. So we have Cl2H nu. So Cl2H nu, so free radical. So yani we get CH Cl2. If we have Cl2 in excess na, Cl2 in excess, so we get bete CCl3. Understood? Here that is not in excess, so we get CHCl2. That's a reaction. That's an important reaction. Now hydrolyze. So any H2O positive, any H2O in the presence of H plus. So what happens? Substitution is going to happen. Now both Cl they are converted to OH. ठीक है बेटे? They are converted to OH. So we have this one. CH, OH, OH, and this is Cl. Now 2OH are unstable, right? 2OH are unstable on one carbon. So there is a loss of water. So OH and H, just remove it. And when you remove it, you get C double bond OH and here Cl. Clear? If Cl2H nu is in excess, if it is in excess, so you get with a COH, OH, which further converts into C double bond OH because two OH are unstable on one carbon. So removal of water, we get carboxylic acid. That's the case. Please learn it. Okay. Now let's do next question, bete. Let's do next question. So next question is based on the series of regions, right? So we have C2H5Br. We have C2H5Br in presence of alcoholic KOH. So see, CH2H, then CH2Br. This is CH2CH2Br. Alcoholic KOH, what you need to do? Dehydrohalogenation to remove HBr. We have to perform beta elimination. Beta elimination. So what happens? OH minus takes this hydrogen, electron of this bond shifts over here and Br leaves. So we get CH2 double bond CH2. ठीक है, तो this is a next. Br2 in presence of CCl4. So Br2 in the presence of CCl4, so we get anti-addition product. So CH2Br and here CH2Br. Anti. We have to add bromine across the double bond. Next, KCN excess. KCN excess. Again, nucleophilic substitution. So now Br is replaced with Cn. Br is replaced with Cn. CH2 Cn. ठीक है. Next, hydrolysis excess. H2O positive excess. Now Cn on hydrolysis gives carboxylic acid. Carboxylic acid. See how to do hydrolysis? C triple bond N. Hydrolysis means breaking of bond in presence of water, either in acidic medium or basic medium. So see, nitrogen is more electronegative. So delta negative on nitrogen and delta positive on carbon because this is more electronegative. So if I want to dissociate three bonds, so put H, H, H. And here put OH, OH, OH. Now 2OH are unstable on one carbon. So rapid loss of water. So here we get C double bond OH. See, C, OH or O double bond. Plus we get NH3. Okay? So we get this acid. Clear? Now see. Oh, malonic acid, oxalic acid, succinic acid, gluconic acid. So how to learn this? We have Ohm's gap, OMS gap. So this is oxalic acid. So oxalic acid is COH, COH. Now just put one CH2. So in M, malonic, we have to write COH, CH2, COH. Now this is succinic. So we get COH, CH2, CH2, COH. ठीक है? So in succinic, so we get here succinic acid. ठीक है? Answer is this. G, gluconic. You have to put one CH2. A, adipic. And P, filmic. Just add one CH2. Successive addition of CH2. Clear? Now, let's do this question. Major product of this, again addition. Can you see this? There are lots of questions which are basically asked on Markovnikov and anti-Markovnikov. So you should know the regions well. You should know what is Markovnikov addition, what is anti-Markovnikov addition. So that's a very important aspect of this chapter. Okay, so now DCl. Again, we have to do Markovnikov. So carbocation is stable over here. So this is CH3 and we put D over here. right? We put D over here. So now Cl minus comes over here beta. ठीक है? So we get CH3 and here we write Cl. ठीक है? So answer is this only. Answer is this. Acha, one more thing. If you see over here, so this is the chiral, है ना? This is the chiral one. ठीक है, तो यहाँ पे पूरा racemic product मिलेगा. We get racemic product. ठीक है? That's it. Now see, this is the chiral center, na? This is the chiral center. In the product we have chiral center. See, we have one chlorine over here, one CH3 over here, one CH2 deuterium, and this is CH2. So we have four different groups. So this is the chiral center. So if we have the chiral center, so we can say that we can get plus or minus, or we can say we can get R or S. So it depends on the option which should be the answer. Okay, now that's it. We have discussed enough questions related to hydrocarbons, and if you see, we have discussed so many concepts which are related to alcohols, normal reaction mechanism and all. So in that way, we are going to do organic chemistry. We will do lots of questions, right? I hope this will give you enough clarity about the organic chemistry reactions, basic mechanisms. Okay, but you have to revise your own notes completely in order to understand the questions. Okay, so that's it from my side. In the next video, I'm going to take the haloalkanes and haloarenes. Very easy and small chapter there, but there are questions from that chapter, right? So we will do enough questions so that you can get enough clarity. Okay, that's it. So now if you like this video, then you can drop a comment, right? And you can also join PracBee for one-to-one doubt clearing session and all. So that's it from my side. See you in the next video, next class. Bye. Take care.